Hey class, Mr. Muhyiddin here with a quick example from our practice test regarding implicit differentiation. So here we're given a traditional problem. We're given an implicitly defined function where x's and y's, independent and dependent variables, are mixed, and we have to find the derivative with respect to x of y. So we're going to use the derivative operator to help us with this. So we're going to take the derivative of both sides, which doesn't really reveal a whole lot given that one of the sides is fairly blank to begin with. So the derivative of the right-hand side is 0 because it doesn't change, it's constant. In fact, it is 0. The derivative of this sum is going to be the sum of the derivatives. So since you have a match, so to speak, of the variables here, the derivative is going to be simply straightforward 2x, and the rest of it's a little more complicated. So I might actually need some more room than just that. So let me put the 2x further away here. Get the pen to work. Okay, 2x. So the next term is a product rule problem. The way I know that is because I have two functions, x and y, and they're being multiplied together. Okay, so the product rule states that you take the derivative of the first, so derivative of x with respect to x is just 1, times the second function, plus the first function times the derivative of the second function. Well, what's the derivative of y? Well, duh, it's literally the derivative of y, dy dx. Some people like to write it as y prime. That's perfectly fine. When we get into related rates in a couple of days, this notation is a bit more preferred, but do as you will. The change in with respect to x of y cubed is a little funky. So sometimes people have trouble understanding this. So let me do this here in this shrub of thought. Imagine I were to write this as y of x to the third power. So this might make it a bit more clear. So what's the derivative with respect to x of this? Well, let's see. The outer function is 3y of x squared times the derivative of the inside part, which would be y prime of x. So this is where the dy dx and the chain rule comes when you're doing implicit differentiation. So literally it'll be 3y squared times dy dx. So there's your three parts. There's the 2x, there's the middle term, and there's the third term. So all it is now is a little bit of algebra. So let's figure out which terms have no dy dx attached to them, free terms in a sense. So this one has nothing attached to it, this one has nothing attached to it, and that's it. So I'm going to go ahead and relegate them over to the other side. So if I move 2x to the right-hand side, it'll be negative 2x, and if I remove positive 1y, it'll be negative y. And I'm left with x dy dx here in this raspberry sherbet color, and plus 3y squared dy dx. So I'm solving for dy dx, as we're looking for the slope function, the derivative. So I'm going to factor dy dx out of both pieces, leaving me with x and 3y squared respectively. And without too much of a sweat, we can divide by both sides, or divide both sides by what's being multiplied. So x plus 3y squared. And hey, we have our answer. The rate of change of this function, which would be a pain in the butt to solve explicitly, is implicitly given as this. There you go.